Hello, this is instructor Rick Powers from Western Technical College, Basic Statistics. Lesson 33, Hypothesis Testing, Other Methods. As history has unfolded, the classical method of doing hypothesis testing became less common. However, many of the terms and processes still have affected the research traditions. Another method of hypothesis testing is called the p-value method. Note that the p is usually capitalized, but not always. In this method, as mentioned previously, the actual probability of having an unusual result is calculated. By using this method, many people have the incorrect impressions that low p-values clearly indicate better results or safer conclusions. Actually, low p-values depend on what assumptions are being made and must be carefully evaluated. The beginning of this method is the same, using the null and alternative hypotheses. The next step is also the same, determining the test value. However, the test value is then used to determine the area of the tail, or the tails. If using a two-tailed test, the area is multiplied by 2. Big idea. If the p-value is less than alpha, we reject the null hypothesis. The area of the tail indicates the probability of having an extreme sample if the population number were the standard number. So a low p-value is what we want in order to say that the sample number is not just a random value, but is significantly different from the standard number. Using the example from the previous section, we found that the test value was z equals 3.278. Technology will show that the right-tailed area for this z-score is about 0.0005. Again, if we use technology from the beginning of the problem, we might get a different answer due to the rounding of the 11% from the original information. Since the p-value is less than alpha, we reject the null hypothesis. This is the same conclusion as previously given. In fact, p-value will always have the same result as the classical method. It's just stated in a different way. The next method of hypothesis testing is the confidence interval method. As described previously, confidence intervals give us more information about our results, so this may be a preferred method. The initial steps of constructing the hypotheses are the same. However, there's no need for a test value or for a critical value. We simply create the confidence interval based on the sample numbers and using a confidence level of 1 minus alpha. Big idea. If the confidence interval does not contain the value in the null hypothesis, then we reject the null hypothesis. We have already discussed this idea when we went over confidence intervals. Since the confidence interval shows us where we expect the population measure to be, then we can easily compare any number to that interval. And if the interval is separated from the number in the null hypothesis, then there is a difference. Consider the same example. For a sample proportion of 11% and a sample size of 568, we'll round off the number of successes to 62. Then the 95% confidence interval is 8.4% to 13.5%. Therefore, the population proportion must be higher than the standard number of 7.4%. One final note, because confidence intervals are always two-tailed, then sometimes we will not be able to prove a conclusion using this method where the other methods would be able to. This is a trade-off for getting more information about the actual population number. End of lesson 33.